For the moment, let's consider a scenario in which a company has created this test that 92% of the time it shows that the person has whatever disease the test is supposed to detect. Now, all I want to do at the moment is talk about what happens if you were to sample from this population. So the drug company gives you the number 92%. But now we know from studying sampling distributions that 92% is really the center of a distribution. And if we look at samples of a particular size, then we know that when we sample, we're going to get different proportions other than the 92% most likely. So for example, if my sample size is 200, then one standard deviation is about 0.01918 or 122. And since I'm expecting at least 10 successes and 10 failures, the distribution right now is roughly normal. So let's pretend for a moment that it is exactly normal. And here I have the distribution. You'll notice that I have 92% here is the center of this distribution. But what this represents are all possible values of p hat. And while the center is 92%, if I sample, for example, 93% is possible, so it's 94, 95, 96. Notice as it starts becoming a little less likely that you're going to see this number. Likewise, on the other end, it's possible I'll see a sample proportion of 91%, 90%, 89%, and again, the further you get away from 92%, the less likely it is that this is going to happen. But it still can happen. So that's the one thing you're going to have to keep in mind in considering what you're about to read, is that while we're quoted a particular number, a center, when we sample, we can get lots of variation depending on the sample size. So for example, if the sample size is 500 instead of 200 for this example, you can see that there's a little less variability. So here's for a sample size of 500, and you'll notice now that getting a sample average of 89% or less is less likely than if you were looking at a sample size of 200. So these are all sample sizes of 200. Getting an 89% or less is not very likely, but definitely more likely than if I were to sample 500 numbers. So here's the logical problem that you're about to encounter. What we're going to do is create a test about the center of this distribution. What we're going to say is this center correct? So for example, the drug company says that 92% of the time it can detect this particular disease. Now, typically, one direction is not a problem, the other direction is a problem. So if it turned out that the test is even better than this, instead of 92%, let's say that it was 95% effective, meaning the center is truly not 92% but 95%, then that's even better. So we're not going to worry about that. What we would worry about is in the other direction. If the test turned out to be less effective than what was quoted, that is a problem. So for example, if I were to sample 200 numbers, what would happen if I got 88%? Well, again, I can't really look at a single number. It doesn't tell me much. So I'm going to look at a range of numbers. 88%. I would ask the following question. If the center is really 92%, what's the likelihood of getting 88%? Or something further away from 92%. We could do this very quickly, since I'm assuming it's approximately normal distributed. I can just do the following. And again, it's going to be rough, so I'm just going to put this here to save some time. I see that getting that number, 88% or anything less than it, has about a 1.85% of occurring. So getting any number in this region is really not very likely if the center is 92%. So at this point, I might be willing to believe that the 92% is not right. And the reason I'm getting a number as far away from 92% as 88% is because maybe the center is not 92%. Maybe the center is something else that's actually lower than 92%. So for example, what would happen if instead of really being 92% like the company said, what if it had been 87%? So now I have another distribution, same sample size, it's 200, but the center now is at 87%. I'm going to superimpose these two together. As a matter of fact, let me keep them apart for a moment. You'll notice under 87% success rate, the value 88% is way more likely to occur. As a matter of fact, it's in a region right now, the 88%, where these sample proportions are more likely to occur. Way more likely to occur. So for example, here I asked, what's the chance of probability that I would get a sample proportion as low as 88% or even lower? This was the answer. But had this been the center, the answer would have been almost 70%. So it's a very, very likely number. So again, if I superimpose these two together, I get this picture right here. So you'll notice both axes contain the 88%, but under two very different distributions, two very different scenarios. What we're going to do is run a test based on what we think is correct, and then ask the question, how likely is it to get some number that we actually get from our sample if the center is correct? So again, we cannot expect to get that number, the one that's quoted to us when we actually sample. Most likely we're not going to get that. We're going to get something else.